Welcome back. In the previous lecture, we understood about the combiners. But in the end, we said we got to use the combiners with caution. Why do we say that? Let us try to understand that as a part of this lecture. Now, just to revise, combiner works on the mapper output before it is sent to the reducer. You can see it is taking the output of mapper and combines the results and sends it to the reducer. We have used the reducer logic directly as a combiner, but we understood we need to be cautious. Why do we say that? We got to ensure that whenever we use a combiner, the final result, what we want as a part of our data analysis shouldn't be changed. Whether we use a combiner or not, what is that we want? We want to ensure that the final output shouldn't impact whether we are using combiner or not. Result of the map produced with and without combiner should be same. Combiner should not change the logic of the processing. That is what is the requirement. Assume whenever you are trying to find the maximum, minimum and sum of some data. In this case, we can definitely go ahead and use the reducers as combiners. There wouldn't be any impact of using the reducer logic as combiner. Why do we say that? Let us take an example. Here we want to find the maximum of all these numbers. Let us say these are the output of each of the mappers. Mapper 1, mapper 2, mapper 3. These are the combiners C1, C2 and C3. Let us say we do not have a combiners. In that case, reducer takes the input of all these things and finds the maximum. What is the maximum? You can see 7 is the maximum coming here, 11 is the maximum coming here, 16 is the maximum. Okay, 16 is the maximum if all the results of the mappers are directly sent to the reducer. Let us introduce the combiners here. When we introduce the combiner here, what it does is it will try to find the maximum from here. What is the maximum here? 7 is the maximum. Then what is the maximum here? 11 is the maximum here. What is the maximum here? 16 is the maximum here. Instead of sending all these values to the reducer, since combiner has already combined the results of the mapper, only these three values will be sent to the reducer. Out of this, which is the maximum? Out of 7, 11 and 16, the maximum is again 16. So immaterial of whether we are using the combiner or not, the result is same. We are using the same logic as that of a reducer in combiner. The result is same. That is excellent. So we can use the reducer as combiner. We can use the reducer logic as a combiner logic here. The same thing applies here also. Minimum. In this case, minimum out of this is 2. Here is 0. Here is 3. Out of all this, if you only reducer has to take, the minimum is 0. And now combiner is combining the logic and it finds the minimum out of this 2. Minimum out of this is 0. Minimum out of this is 3. Now it will send this to the reducer. Minimum out of all these 3 is 0. There is no change when reducer is doing its job on its own and when the combiner is introduced by using the reducer logic. The same thing happens in sum as well, right? Simple. You can do this calculation on your own. Now, let us take an example here. If we want to calculate the average of temperature, can you just think and tell me whether we can use the reducer as a combiner logic here? The same logic whatever we are using as a reducer, can we use the same logic as a part of the combiner to find the average? Let us take an example and find out. In this case, we are trying to find the average temperature in a day. Remember, not the maximum temperature, average temperature. Ideally, what we would do is, assuming that there is no combiner here, what will be the average of these three, because all of them come from the same date? 50 plus 52 plus 49 is equal to 151 divided by 3. It is 50.3. And let us try to combine these results. 48 plus 54 plus 55 is equal to 157, and divided by 3 is 52.33. We have just rounded it off to 52.3. This is the actual result without a combiner. Now let us introduce a combiner and see what would be the result. Okay, we are introducing a combiner. This is the result without a combiner. Let us calculate here. What would happen is, if you introduce a combiner, in this case, these two will get into combiner 1, this will get into combiner 2, these two will get into combiner 3. 50 plus 52 is equal to 102 divided by 2 is 51. This is the combiner result. We are yet to arrive at the reducer result. Then let us take this here. Here will be 49 for the date of 12, and here 48. Now between 54, and because both of them are from the same date, combiner will combine that. 54 plus 55 is 109 by 2 is 54.5. Remember, these are the result from the combiner. Now what we got to do is, we have to combine these two at the reducer phase. We have to combine these two at the reducer phase. So now let us combine them. This is happening at the reducer phase. Now 49 plus 51 is equal to 100 divided by 2 is 50. And now 54.5 plus 48 is 102.5 divided by 2 is 51.25. Is it the same? It is not. Is it right? It is not at all right. This is what is the output of the results when we use the reducer logic as a combiner logic. In this case, it is not right. Final result is not right. Why is that? That is because we cannot have a average of a set of numbers equal to average of averages. That will not work. It may work when we say maximum, minimum, and sum. When you take a case of average, it will not work. In this case, we cannot have the same logic of reducer as combiner. We got to have combiner and reducer logic different. Just to summarize, we can have a reducer as a combiner in certain scenarios like max, min, and sum. But combiner and reducer functions have to be different in certain scenarios like average. One of the very important point to be taken care, there should not be any impact on the final result. Awesome. We learned about why do we need to use combiners with caution. Thank you.